Okay, for the second half of the review, I'm going to focus on the concept of Ksp. Again, Ksp refers to the equilibrium that is established when something that is technically insoluble is both dissolving and recrystallizing. So again, when things were insoluble, we used to say like none of it separates in solvent, but really a little bit does. And Ksp is the measure of that equilibrium that's established. So for question 1 here, which of the following salts would go to an equilibrium? Now, equilibrium means we have to have something going both directions here. So that gets rid of all these soluble substances. These would pretty much go to completion and we would only have ions and no solid left. So we're always going to look for that insoluble substance if it asks which ones could have a Ksp or an equilibrium. Okay, question 2. What is true at equilibrium involving solids dissolving? And I kind of just answered that, but the rate of dissolution, or dissolving is another word for that, is equal to the rate of recrystallization when ions turn back into solid. Okay, for question 3, the solubility product expression is just the K value setup. Now for all of these equilibria, we can get rid of these solids right away. Those would not be in here. So the Ksp value would equal the concentration of the ions raised to the exponent of the coefficient. So for this first one, it would be the concentration of Ag plus to the first times the concentration of OH minus to the first. For the second reaction, it would be Ksp equals the concentration of Ag plus squared times the concentration of S minus 2 to the first. And for the third Ksp expression, Ksp would be equal to the concentration of Ag plus cubed times the concentration of PO4 3 minus. Okay, so these would be the solubility product expressions. Now for question 4, which of the following salts is most soluble? Now what I would like us to be able to do in class is look at binary salts. Binary, again, means it's made up of just 2 ions when separated. So notice we have like 1A and 1B here, 1A and 1C, 1A and 1D. So I would give you problems kind of like this and avoid ones that, have more than 1 ion when they're dissolving. So we can just look at these Ksp values and compare these directly as long as these are binary, which is what you're going to do. Now most soluble. This means has the highest Ksp value, the highest concentration of ions over solid. So what we have here is this one would be the highest number. If we think of like 1 times 10 to the negative 4th is like 0.0001. Negative 5th has 4 zeros. This one's got 5 zeros. So AB would be the most soluble salt. So when you're ever asked for which is the most soluble, whichever Ksp value is the largest is the most soluble. Okay, 6 and 7 kind of go back to earlier in the year stuff, but help us set up Ksp problems. So if the concentration of Ag plus in AgOH is 1 times 10 to the negative 4th molar, what is the concentration of the OH minus? Now for all of these problems, even before we set up the Ksp expression, I think what is the most helpful is to write down the dissolving process. So AgOH will dissociate into Ag plus and OH minus ions. We can kind of avoid the solid and aqueous for now, just for this setup if you'd like. This means that if the concentration of Ag plus is 1 times 10 to the negative 4, check this out. This is all a 1 to 1 to 1 ratio. Again, a 1 to 1 ratio as they dissolve. So if this is 1 times 10 to the negative 4th, then this one would also have to be 1 times 10 to the negative 4th, because that's a 1 to 1 ratio. So we got B there. Okay, for question 7, if the concentration of Ag plus and Ag2CO3 is 1 times 10 to the negative 6 molar, what's the concentration of the CO3? So again, we start out by writing out the ionic compound. We then separate it into its ions with the correct coefficient. Notice that we have 2 Ags here. So we have 2 Ag plus, and we have 1 CO3 2 minus. This one is a 2 to 1 ratio. For every 1 mole of CO3 ions, we would have twice as much silver ions. Now, if the Ag is 1 times 10 to the negative 6 molar, and the CO3 must be half as much, now I guess this would be 5 times 10 to the negative 5th, but I kind of put these out of scientific notation so we could see it more easily. So this would be half as much, so 0.5 times 10 to the negative 6. So we got A there. Okay, now the last two types of problems we'd be doing with KSP is we'd be solving for values. And there's two things. You're either going to be solving for the KSP or you're going to be solving for something called the solubility, and that would represent X. So let's look at this first problem. Let's really try and hone in on what we're trying to solve for. Calculate the KSP. So there we go. We're solving for KSP. For calcium fluoride, if a saturated solution, just means we're at equilibrium, contains 2.15 times 10 to the negative 4th molar Ca plus 2. Now I gave you these last two problems to get you ready for this one. And again, I would always start out by writing this dissolving process. So if CaF2 has 1 calcium for every 2 fluorines. Again, this is a 1 to 1 to 2 ratio. For every 1 calcium, we have twice as much fluorine. It said that the calcium was 2.15 times 10 to the negative 4th molar, which means if that's this concentration, the F minus must be 4.3 times 10 to the negative 4th molar. It has to be twice as much if we're at that equilibrium value, and we would be if it said the word saturated. Or it would be if I gave you a problem like this anyways. Okay, next. Now I would go and set up the KSP expression. KSP will equal the concentration of calcium to the first power because it has a coefficient of 1 times the concentration of fluorine ions squared because it has a coefficient of 2. So that means KSP would equal 2.15 times 10 to the negative 4th molar times 4.3 times 10 to the negative 4th molar squared. So again, on the calculator, I would just go 4.3 E minus 4 squared times 2.15 E minus 4. And we get 3.97 blah, 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 times 10 to the negative 11th. I will not be giving you any distractors on quizzes and test things that have scientific notation or sig figs is the reason they're off. So we can just say, like, how about 3.98 times 10 to the negative 11th. And when we do KSP answers, we're not going to have units for KSP. This would just represent, again, how many ions we have per how much solid. Okay, the last question. PbI2 is an insoluble salt with a KSP of 1.4 times 10 to the negative 8. And of course it's insoluble if it gives us a KSP. What's the solubility of Pb plus 2 at equilibrium? So this one we are solving for some sort of X value. Okay, first thing, let's write out the dissolving process. PbI2 will dissociate into Pb plus 2 and 2 iodine ions, 2I minus. Now, this is a 1 to 2 ratio. So when this is a 1 to 2 ratio, we're just going to make up values, and let's say X. It's the easiest thing. Pb would be X, and if Pb plus 2 is X, that means I2 would be, it's a 1 to 2 ratio, so 2X. Okay, so now that we've set up our little X values here, let's write out the KSP expression. KSP would equal the concentration of lead to the first power times the concentration of I minus squared. And notice that the concentration of I minus has to be double the lead. So my KSP was 1.4 times 10 to the negative 8th. We're always given that when we're solving for X. And that would equal X times, be careful that this goes in the parentheses, 2X squared. Now, what is 2X squared? You got to square the X, but you also have to square that 2. So this would be 1.4 times 10 to the negative 8th is equal X times 4X squared, which equals 4X cubed. Okay, now to solve for X, I would take 1.4 times 10 to the negative 8th, 1.4 E minus 8. I would divide it by 4. And then again, when you have something to the third power, the opposite of that is a cubed root. And if you can't find the button, I always just do, you could raise it to the 1/3 power. And we get x is equal to 1.5 times 10 to the negative third molar. And now we got to go back and check out the question. This was asking for what is the solubility of Pb2 plus, and notice that the Pb2 plus was x. So this is the answer. And I guess if it were asking for what's the solubility of I2 minus, it would be twice as much. But we're just solving for Pb2 plus here, which is x, so this is our final answer. Okay, I hope this helped get you ready for the KSP portion of the Unit 9B quiz. And let me know if you have any questions.